Everyone, Wazoo here, and today we are going to be exploring how to make your own to-do application using just C. We're going to be looking at creating a console app on Windows. This video is aimed at the beginner C programmer. I'll try and explain everything as I'm walking through putting the code together, but I encourage you to pause or use the chapter search to skip ahead to the section that you're interested in either repeating or finding more about. The code that we'll be building today, I'll make it available on my GitHub repository. Please feel free to share this video, like and subscribe to the channel, and just leave a comment down below how you thought things went, or maybe what changes you would suggest for another video or a follow-up to this one. Okay, so as you can see, I've got a empty Visual Studio 2022 in front of me. I've got a main.c file, and I've just built a console app from the wizard template stuff. So let's go ahead and get started. So because of some of the string manipulation we're going to be doing, we'll have to define a preprocessor directive called CRT secure no warnings. You don't really need to understand what it's doing right now. It's an error that will come up if we don't declare it right now. It'll be an error that'll come up eventually, and don't let it confuse you. It's just a warning on how to manipulate string data in C with the standard C string functions. And then we'll declare two more preprocessor directives to just contain constants that we'll make reference to from our to-do application. So we'll name one max description length, and we'll give that a value of 256. And we'll come up with another one called initial capacity, and we will declare that as 10. Next, we will declare the structure object that'll contain and hold the data for each to-do item. Okay, so here we've declared a structure using the keyword struct, and we've given it the name to-do item. We've got an integer for tracking an ID for each one. We've got a character array to hold the description, basically the text of what the to-do will be. And then we've got a Boolean true or false if we have completed this to-do item. Next, we're going to create some global variables to just keep track of our to-do item list. Okay, so we've got 4 variables that I've declared that we're working with. We have a pointer to a to-do item list, and we will be dynamically allocating memory. I'll be showing you how to do that using Malloc and free. Since we don't know the size of our to-do list when it's running, then we need to do something called dynamic memory allocation. And this just means that as we add to-do items to our to-do list, we are setting aside enough memory to make sure we can create each instance of a to-do item properly. And then we've got the to-do count and to-do capacity to just keep track of our list as it's growing. And then we've got a next ID variable that we'll just use to track what we're populating the ID field with. So let's start off with our main function. This will be the main entry point into our application. Int main void, and we'll return 0. And I think what we're going to do is we are going to create a do while loop that will just loop forever until the user decides to exit the program. So I'll show you what we mean here. So let's create a do loop while choice does not equal to 6. While the value of choice is not equal to 6, we will keep going through the loop. We're going to declare it right here. So it's an integer. And so these are the operations that we're going to support in this little application. So we're going to be displaying a menu. And so we can either add a to-do, list the existing to-dos, mark a to-do as completed, delete a to-do, save the to-dos to a file, or exit. And then we'll be presented with a prompt that just says enter your choice. So we're going to keep doing this, and the only one we're going to implement first is exit. So we're going to use a function called scanf, and it'll accept an integer from the keyboard, and we're looking for a number that we're going to be storing into the variable choice. So if they enter like a character or a function key, then this is the area where we'll fall into. So then what we have to do is sometimes, we'll print out a message just saying invalid input. Please enter a number. And then we'll append a carriage return at the end of that line. And then sometimes what happens with taking input from the console is that the C libraries will sometimes leave leftover characters in the input buffer that we're looking at. And then we can create a basically infinite loop because we're reading something and not taking care of it. So the way to do that is to just call getChar, and then we use a continue to skip ahead to the next iteration of the loop. Okay, so basically what we want to do is we want to eat the carriage return that's in the input buffer. Finally, we can use a switch statement to test which number our user entered. So we put that into a switch, and we're going to be looking at the choice variable. Remember, it's an integer that we are saving the number from the menu into. So right now we're just going to exit. So case 6, we've hit the 6 key, which is exit. Let's print something. So exiting application. Have a great day. And then we want to break from the switch statement. And then maybe our default message will just be something like invalid choice. Please try again. Okay, so we've got our do loop, and that should be all we need to do. Let's give this a shot. Okay, so we've got our list showing up here, add list mark. So nothing will work except for exiting. So first let's try hitting like a character. So let's hit F. Oh, so we've detected that it's not within the number range that we're expecting. So now we need to enter a number. So let's enter 6. And we exit. Awesome.
Perfect.
Okay. So let's go back. We've got our basic loop working now. And when we enter our application, let's go ahead and initialize a new to-do list using that dynamic memory allocation I briefly mentioned earlier. So let's give ourselves a function called initialize to-do list. And let's define it here. Okay, so what we want to do is we want to set the to-do capacity variable to be that initial capacity const value. And then we want to initialize our to-do list, which is that pointer. So we first have to cast it to the to-do item pointer. And then we want to use Malloc. And we need the size of the to-do item structure times the to-do capacity. So we are declaring enough memory space to contain enough to-do items that matches the initial capacity value, which right now is 10. So we can check if there's been an error. So if to-do list equals null, then print an error, failed to allocate memory, bad. So then let's use a function called exit. And basically, this is a terrible thing if we can't allocate enough memory for a couple of bytes for our to-do items. Okay, so we will reset our to-do count global variable to be 0 and our next ID to be equal to 1. Okay, so we are initializing our to-do list, which we're calling from the main app. Let's go ahead and write a function to clean up the memory that we allocated. When you're working with dynamic memory, such as Malloc, and there's another function called calloc. If you're using any of these to reserve dynamic memory, then you should use the free function to free up the memory that we've reserved. So let's write this function now. So we're going to free the to-do list. So if to-do list, if that pointer does not equal to null already, then what we're going to do is free the to-do list. We're going to call free on that to-do list to free up the memory. and then set that pointer to null. And then we're just going to reset all those other variables. Okay, so right at the end of our application here, let's call free to do list. And just to make sure that we don't have any issues, let's run it. Okay, we get our menu, everything looks all right. Let's exit. Okay, so let's go ahead and add a new to-do. So what we're going to do in this section here where we're declaring the integer choice, we're going to declare another variable here, just called temp description. And we'll make it the same size as that other array that's in the to-do item struct. And then we'll create a temp ID variable. Okay, so back down in the switch statement, if we want to add a new to-do, so case number 1. So first, let's say enter the new to-do description. So we want to use a function called fgetS. We want to stuff that into temp description. Size of temp underscore description. And we're taking it from the standard input. So the user will type in the new description that they want. It will also pass in the return key once we hit enter on our string. We have to remove that from this temp underscore description character array. So this function will take in the temp description, so our character array, and then another string, which is what we don't want to include in the resulting temp underscore description character array, and it will remove that /n, that carriage return from the end of temp description. Okay, and then let's call a add to do function passing in that temp description. And then don't forget to call the break. Done with adding a to do. Okay, so let's create this right now. So void add to do. And we're passing in a description character array. So if the length of the string being passed in is 0, then let's get out of here. Description cannot be empty. Return. So let's return back to that do loop. Okay, so what we want to do is get our list here and use the current to do count. Okay, and then what we want to use, so basically we want to assign it the current value of next ID, and then we want to increment that value by 1 automatically, so that as we add new to-dos to the list, they will each have IDs that are incrementing in sequence. So then we want to use a function called string copy, to-do list, to-do count. So we want to string copy, we want to copy the contents of the description string that we're passing into this function into the to-do list item. And then we want to set the completed flag to false. And then we want to increment the to-do count. And then finally just print a message. Okay, so this is a long string, but what we want to do is we want to just display to the user that we've added a new to-do item. We're going to display the ID, which remember it's to-do count. It's now to-do count -1 because we've incremented to-do count here. So it is the earlier index of the item in the to-do list array. We're going to be printing out the ID and the description. I just realized that one thing we're going to run into is that if we keep adding to-do items, then if we go beyond the capacity of our to-do list, then we are going to be working with memory that we haven't properly reserved. And so we'll probably get a lot of issues. So let's create a new function here, and we'll just call it ensure capacity. All this is going to do is check our to-do count, make sure we have a valid number, and then allocate more memory if we need to add more memory. So let's create it here. So if to-do count is bigger than equal to to-do capacity. Okay, so if we're working with more items than what we've reserved, let's double the current to-do capacity variable by 2, and then let's allocate. So we're using a function called realloc. So we want to reallocate the memory of to-do list, size of to-do item times to-do capacity. And then again, we want to check if the returned memory pointer is null, then there's going to be an error. Okay, so if our to-do count is bigger than equal to our to-do capacity value, then double the size of the to-do capacity value. Use realloc to create a larger space of memory to contain the longer to-do item list. Check to see if that's failed. Otherwise, assign the new chunk of memory to our to-do list pointer, and then just display a message saying that we've increased the capacity of this to-do list. So let's go ahead, and what we're going to do is set this initial capacity to 2. And then that way we will see that message right away. Okay, so we want to add a to-do. So we added that first to-do with an ID of 1, and now if we add another to-do, we should have a second to-do, okay? And now if we add a third one, it should be beyond that to-do capacity count, and we will go into that ensure capacity function. So let's add a to-do, and let's say third to-do. Okay, so we've got our info message here of resizing that to-do list to 4 capacity, and then a success that we've added that new to-do item. A handy function to write right now would be to list the items that we have in a to-do list. So let's go ahead and do that. And I'm also going to update this language here to resize to-do list to capacity of 4. Resize to-do list to capacity of %d. Let's just change that language a little bit. I know, minor thing. Okay, so let's work on a function to list all the to-dos. So back in our switch statement, listing the to-dos is number 2. So let's add a new case number 2. We want to call list to-dos, and then break. And let's create a function here called list to-dos. Okay, so if our to-do count is 0, then just print a message saying the to-do list is empty and return. So get out of this function. So first we're going to print out like a small header of current to-dos, maybe current to-do items, and we will display a value using to-do count of how many items are in our to-do list. Okay, and then all we're going to do is do a standard for loop. So we're going to initialize our variable to be 0, and we are going to keep incrementing I until we reach the value of to-do count, which is the value of the number of to-do items in our array. And then we are going to basically print out a string to display the ID, the status, so basically if it's complete or not complete, and then the description using the current value of I as the index into that array. And then finally, we're going to be printing just another sort of banner to just let you know that that's the end of the list. So let's give this a shot. We're going to have 0 to-do items in our list. So let's go ahead and add another one. So first to-do, and then we're going to add another one. Second to-do, okay, and then we're going to list them. And here we go. We've got 2 items in our list. ID of 1, status pending, description, and then an ID 2, the status of pending, and the second description. Perfect. So now what we're going to do is we're going to add functionality to mark the to-do that we want as completed. So back in our big switch statement here, this would be number 3. So case number 3. So what we're going to do is we're going to display a little message saying, enter the ID of to do to complete. And then we're going to use that scanf %d again, and we're going to read that into the temp ID variable that we had declared above. So while it is not a number, we will just display invalid input. Please enter a number, and we'll eat that trailing return key. Okay, so we are reading the number input into the temp ID variable, and as long as we are getting a valid number, then we drop out of this condition, and we just need to use a while loop to just make sure that there's no dangling carriage return or new line in that input buffer. And then we call the complete to-do function, passing in the value of this temp ID. So let's write our complete to-do function. Okay, so what we're going to do is create another for loop, and we're going to go through, we're going to start from the index of 0, and we're going to keep incrementing the index by 1 until we reach the maximum amount of to-do items in our array, which is stored in the to-do underscore count variable. And with each to-do item, we're going to compare the ID. We're going to compare the ID of that to-do item with the ID that we've passed in from the keyboard input. And then what we're going to do is check if it is the same ID with what we're working with. We'll check the completed flag, and if it's already marked as completed, then we'll just display a little message saying you've already marked this one completed. Otherwise, we will set the completed value to true, and then just display a message on the console that, yes, we've marked this to-do item as completed, and then we will return. And then if we get to the end of this to-do list without matching the ID that we've inputted, then we'll just display an error that a to-do with the given ID number is not found. So let's try this out. So let's add a to-do. Okay, so we've got a to-do item, one of them. Let's make a list. And so we've got our only to-do item with an ID of 1, a status of pending, and a description. And so let's mark this to-do as completed. And so let's enter the ID of the to-do to complete. And so our ID is 1. And it says success to-do ID 1 marked as complete. And then let's use list again. And we now see that our to-do item is marked as completed.
Perfect.
Okay, we're well on our way here. So let's go ahead and now implement the delete to-do. So case 4. So we want to printf, enter the ID of to-do to delete. So we have to process the input pretty much the same way as we already did right here. So we're going to store that into temp ID. We can just cut and paste the same handler. In fact, we can cut and paste this entire block here, only instead of saying complete to do, we want to say delete to do. So the rest of the functionality is pretty similar. We're scanning for a valid number, which we then make sure that there's no trailing carriage return. Then we call the delete to do function, passing in that number that we entered on the keyboard. Okay, so deleting is a little bit trickier than just adding a new one, because what we want to do is make sure that the item we want to delete exists, delete the right item. Okay, so let's create a variable called foundIndex, and we'll set that to -1. And we're just going to do a for loop going through our to-do list array using the index I to compare the IDs of the to-do item and the given one that we want to delete. If we found the right to-do item, then let's set that index to foundIndex and then break out of this for loop. Okay, next, so if our found index is not equal to -1, so if we found the proper to-do item that we want to delete, what we want to do now is we want to do another for loop, only we'll start at the found index, and we'll go until the to-do count -1. And what we're going to do basically is shift all of the to-do items left in the array, basically to fill the gap of the to-do item that we're trying to delete. Then we need to decrement the to-do count by 1, and that's all we need to do. Then we print a success message that the to-do with the given ID has been deleted. Otherwise, if we don't find the found index, then we just display an error that the to-do with a given ID is not found. So let's try this out. So let's add a to-do. Okay, and then let's delete this to-do. So option 4, enter the ID of the to-do to delete. Let's use 1, and it says success to-do with ID 1 deleted. Let's list our to-dos. And again, it says our to-do list is empty, which is what we want. Okay, so one thing we want to do now is we want to save the contents of our to-do list to a text file. So this will be option number 5 in our list. So let's go down here and let's say case number 5. Okay, we want to save our to-dos. So we want to save to-dos to file, and we'll just call it todos.txt. And then we're going to print a message, to-dos saved to todos.txt. And break. Okay, and then we'll call this. Okay, so we've got a function. We're going to create a function called save underscore todos to file, and then we'll give it the file name, the name of the file name. So we'll just call it todos.txt, and then we'll print out a message saying that the file has been saved. Let's go ahead and write that function now. Save todos to file. So we're going to use the C file libraries. So here we are going to call fopen, and then we'll use the file name that we've passed into this function, so todos.txt, and we want to write to it, so we need to pass in the W for write, and then we need to check the pointer that's returned from file open to see if it's been null. Otherwise, what we want to do is another for loop, and we want to go through the entire to-do list array up until to-do underscore count. Then we want to use a function called fprintf, which we pass in the pointer to the file and then the string of the contents that we want to print. We want to separate the ID, the completed flag, and the description with a semicolon, and I'll show you why shortly. So what this will do is for each to-do item in the array, it will generate a string in that file that contains its ID, whether it's been completed or not, and then the description. And then finally, we're going to close the file up when we finish. So let's go ahead and run this. Okay, so we've got 2 to-dos in our list. Let's go ahead and write that. So 5. Okay, to-do save to-do.txt. If we open up the todos.txt file, you'll see here that we've got each line of the to-do items that were in the list. So we've got the ID of 1, a 0 or a 1 if it's been completed or not, and then the description of the to-do item. So first to-do, second to-do. Okay, so finally what we're going to do, which I think might be handy, is if we're saving the contents of our to-do list to a file, then we should go through and maybe load it upon running our application. So if we want to keep updating our to-do list as we go through the day or go through the week, however long we're tracking items, then we can just keep a persisted list that we're marking complete and moving on with. So back in our main function, after we initialize our to-do list, let's go ahead and load to-dos from file todos.txt. So then let's create this load to-dos from file function. So it's going to be somewhat similar as the save functionality. So we're going to create a handle to the file of the given file name, only we're going to open it with the R flag. So we want to read it and process this file. And we don't want to change the contents of it. We just want to open it for reading. And then what we're going to do is we are going to free up any existing to-do items. So we'll call our free to-do list, and then we'll reinitialize the to-do list. Okay, so what we're going to do is we're going to create a temporary variable to hold each line of that file. We're going to track the ID of the line that we've loaded along with the completed value, and then the value of that description from that same line. And then we also need to track the highest ID found. That way, when we finish loading items and we want to add new items to the list, then we have a valid ID to work with, that we're not overwriting basically existing to-do items. Okay, so this while loop, we're going to put ourselves into a while loop here to get the contents of the line from the open file and store each line into the line character array. So that's all this fgetS is doing. So file get string. And what we're going to do is we are going to parse the entire line that we've read in. So we've got an ID with a semicolon, we've got the 0 or 1 completed flag with a semicolon, and then finally the description of the to-do item. So that's all we need to parse. Okay, so we're going to be looking for this semicolon character within our line string. And so once we find that first one, then what we're going to do is return the position. Sorry, we're going to return a pointer to the first occurrence of that character within the string. And then what we're going to do is convert the remnant of line using a to I. So we're going to convert that text into a integer. So basically, if we have a text of, let's say, 1 as a string, then we're going to convert that into 1 as an actual integer, which is what we need to work with. We're going to do the same thing again to find the next semicolon in that string and convert that next chunk of data to another integer that we're going to call loaded_completed. And then finally, what we're going to do is basically copy the string contents of where we are in that parsed string into the loaded description array, which is a temporary array. And then we're going to remove the /n from the end of that string if one exists. Finally, we're going to call our handy dandy ensure_capacity to make sure that we've got enough space for a new to-do item. And then what we're going to do is copy in the updated values of what we're parsing in from that file into the current index of the to-do list. And then we're going to increase to-do count by 1. And then we're just going to keep track of the IDs and increment our max ID value as we go to make sure that once we're done loading in items, we can add new ones to the list which have a higher ID than what we've loaded in. So once we're finished all this, so we keep going, and while there's lines in our to-dos text file. So once we've completed going through all of these lines, then we just set our next ID variable to be the max ID found plus 1. We close our file, and then we just display a helpful message to the user that we've loaded a number of to-dos from the file name, so todos.txt. So let's go ahead and try that out now. So we've got an existing todos.txt right here, and let's add a new one here. So we'll call it 1. So let's have a completed one called finish tutorial. So it's an ID of 3, and we're going to use 1 and say that it's been completed and that the new description is finish tutorial. And let's put in some garbage data. So let's put in a 4, and let's just say this should not be added. So we've got a valid ID that we can use, but then the rest of the string is not valid. And so theoretically, we should be throwing that away as we load in this to-do list. So let's go ahead and run this. and we shall see what happens. Okay, so here, skipping malformed line in file, missing second semicolon. So we've loaded 3 to-dos from the todos.txt. Let's list them out. And we've got our existing ones from our file plus our completed one, finished tutorial. And we've thrown away the one that had invalid data. So that logic works.
Perfect.
Amazing. Okay, and that's all there is to creating your own console-driven to-do list application that can load and save your to-do items to a text file. You can complete them when you finish things, and you can delete them. If you want to add new ones, you can go ahead and just keep adding away as many items as you want. Awesome. I hope you had as much fun working through this as I did, and I will see you in the next video, folks. Have a good one. Peace.